are not completely surrounded by other nucleons. Do you understand what this means? Okay, now if we imagine the nucleus as a sphere, right, and this contains the nucleons. The nucleons are particles inside this sphere, okay, tiny particles. So inside the sphere, each nucleon will have neighbors, right, but the nucleons on the surface of this sphere will have less neighbors. Now can you imagine this? So that's what this term is about, okay. So that's why this term is smaller than the first term, because on the surface you have lesser nucleons. Now the third term, so the third term is it depends on the atomic number multiplied by the inverted power 1/3 of the mass number A. Okay. So, this accounts for Coulomb repulsion of the positively charged protons in the nucleus. Okay. Okay. You know that whenever there are charged particles, there is a Coulomb field, and the charged particles in the nucleus are the protons, and they are all of the same charge, same kind of charge, right? They are all positive, and therefore there will be a Coulomb repulsion. And since there is a Coulomb repulsion, you can see there is a negative power in this term. Okay. So, the fourth, you know, there are some terms that are adding to this energy, and there are some terms that are reducing this energy depending on it. So, the fourth term, yes, it is a smaller term. Of course, when you are dividing by something, you will get a smaller term, right. Okay. So, the fourth term so this accounts for the decrease in binding energy observed in heavy nuclei with an excess of neutrons. Okay. So, there are cases when n is equal to z this term is equal to what? And when n is not equal to z, this term is equal to this term becomes negative, and in the first case this term becomes
Positive.
no. When n is equal to z, this term becomes yes. And this term delta is known as the pairing energy. This is for symmetry. So, when n is equal to z, the fourth term becomes what's the answer? 0. Is that clear? Do you understand why? Socho. Look at the term and try to understand it. हाँ? नहीं, इसको छोड़ दो. We are talking about this term. Fourth, this one. This one. You can make a photo of the board. And again I will explain that I wrote the right hand side first and the left hand side afterwards, okay. Okay. Do you all understand why the fourth term becomes equal to 0 when n is equal to z? N plus z is equal to a, okay. So, when n is equal to z, you have a minus a is 0, okay, right. Okay. Now, let us see if I can switch this on. Okay. I don't know why their wire is so small, but anyway, let us see if it is working. Yes, it is working. Great. Okay. And I can erase the board now, okay. So, the graph that I wanted to show you, that is what I am going to show you now with an explanation, okay. This graph, you also have this graph in the book, but I am going to show you in a video, okay. Okay. Right. So, now you can switch off the light because I am going to play a video.